see how to analyze the anthropogenic impacts on biodiversity. What are anthropogenic impacts on biodiversity? For instance, we have deforestation. That's a very big problem. We have overfishing, pollution, water pollution, garbage pollution. So there are different ways how the biological diversity is impacted. To analyze this impact, we have different methods. There are some methods that are based on univariate measures. For instance, indexes that are based on species richness. So the effect of disturbance is more evident on abundances. There are indexes based on species evenness. That is the better response to disturbance. And we can use different ways to measure this. For instance, we can use the Simpson index, Caramago index, Smith-Wilson index, and the EQ evenness. The higher is the evenness, the healthier is the area. Indexes that are based on species diversity are also used, but are difficult to evaluate. If you want to compare these impacts, you need to provide good information or really information about the difference. And we use different diversity that includes both information from richness and evenness. This can be confounding. Also, the indexes based on taxonomical or functional diversity can be used. They are very useful to understand the univariate measure of the impacts of biodiversity. I think all of you know about species abundance distribution. Now, these methods try to assess the impacts of biodiversity that moves from log normal, that is a kind of proxy of undisturbed site, to geometrical series, that means that the site is very disturbed. Now, if you remember from the last lectures, we have different ways to show all the abnormalities distributed inside the species. So log normal is the best way because it means that community is healthy and it means that the inside of the community is undisturbed. Geometrical series is what we have kind of big domicile species and it's indicative of disturbance. The best approach is to fit our data to a geometrical series and then calculate the slope m or the slope of rank abundance distribution regression. In this way, we analyze if the site is very disturbed or not, so much disturbed or completely undisturbed, comparing the slope and the regression of the RAT. Low slope means that there is more evenness and so that the site that we are analyzing is undisturbed. High slope means that the evenness is very low and in this case the site is disturbed because there is dominance of species. To avoid the influence of the richness, we can use the evenness of Smith-Wilson. That's very useful in these cases when we want to analyze the impacts of biodiversity. Another way or another parameter of species distribution is to analyze the impacts of biodiversity is the ECDF. What I have taught is the empirical cumulative distribution function, or you can also use the K dominance curves. And the last way is a new system, a new graph that I will be showing you in the next slides, which you will can use to analyze the impact of anthropogenic effects by using the ABC curves. Now, ABC curves are based on the distribution of abundances and biomass. So we use ABC curve to analyze the effect of impacts of biodiversity, because biomass grow in a different way with respect to biodiversity when the site is disturbed or not. So if you remember from the last lecture that we started to analyze what is an ECD curve, that is the empirical cumulative distribution function curve. Now the empirical cumulative distribution function is a powerful graph to understand what are the anthropogenic impacts on biodiversity. For instance, in this example, you will find three curves, and the highest one is the undisturbed forest, the intermediate one is a disturbed forest, and the lowest one is an agricultural field. You see the agricultural field, for instance, as the intermediate part of the cube that is quite parallel or more or less parallel to the y-axis. If compared to undisturbed forest, you will see that this is the uh, agricultural field. The intermediate part is parallel to the y-axis. Moreover, the undisturbed forest is the left low part that is higher than the other two groups. This means that the number of rare species in the undisturbed forest is higher than the other two. Another way to analyze impacts on biodiversity is the K-dominance curve. Now you see in this example there are two curves, and the highest one means that the community in that case has more biological diversity and is more diverse than the second one. So the curve that's placed itself on top of the graph is more diverse, and the curve that is below the others is the less diverse. A third interesting way to analyze the effects of anthropogenic impact on biodiversity is the abundance biomass curve, or the ABC curve. From this curve, you can monitor what are the effects. Now, for example, you will see in here there are three different communities. One is undisturbed, the second one is moderately disturbed, and the third one is highly disturbed. Now if you put on the x-axis the species rank as log, and on the y-axis the biomass or the abundance cumulative of each species, you will see that in undisturbed places biomass curve is always over the abundance curve. It means that the biomass of the system is higher than single number of species. In the intermediate disturbance side, instead, you will see that the two curves cross many times. It means that abundance can be sometimes higher than biomass, and this is because some species grow faster than the other because the site is disturbed. For instance, by other species is that this is the condition that you can see on the disturbed side. The number of individuals is very high because there are pioneer or invasive species that can arrive in and they can grow fast, but they cannot accumulate much biomass. So analyzing these two things, when you see that biomass is higher than abundance, then you can understand that the site is undisturbed. When they cross many times, that means the society is moderately disturbed, and when the abundance curve is higher than the biomass curve, you can understand that the society is highly disturbed. There is also a mathematical way that is used for calculation of ABC curves, the effects on diversity, and this is called the W index. W index is very simple because it's just the sum of BI minus AI by 50 into S minus 1. It is multiplied by the number of species in the system. Now BI is simply the biomass of each species of the rank I, and AI is the number of individuals of each species of rank I. You just need to keep in mind that AI and BI can refer to different species of different ranks because they rank differently in that particular community. They are according to biomass or according to their biodiversity. Anyway, from more disturbed sites, you have an index that is higher, greater than 0, and which is near about 0 is moderately disturbed site, and to negative indexes have disturbed site. So if you value the value you obtain for W statistics or W index is positive, you can say that this site is undisturbed. If it's around 0, the site is moderately disturbed, and if it's negative, it's sure that the site is highly disturbed. The third way to assess the impact on biodiversity are methods based on multivariate measures. Now, these are called as principal component analysis or PCA or coordinate analysis, but sometimes they have limited use. So is it better to use biodiversity index? For instance, if we want to use multivariate measure, we can use Sorensen or Jacquard, or even better, Bray-Curtis or Cow-Sorensen. Cow-Jacquard to evaluate the effect of disturbance on community. Because these indexes are influenced by the most abundant species, it's very important to increase the number of replicates for each treatment. For instance, the disturbed and not disturbed site, and utilize both the indexes. For instance, presence, the data and the abundance in indexes. Also, it's possible to calculate some kind of index of disturbance of the community, or what we call the IDC or index of biotic integrity, that is called the IBI. Now, to compare standard level of biodiversity to close not so disturbed areas, in comparison to those of the disturbed areas, we can have a different comparison to understand how big is the impact on the biodiversity of the community. So that's all for today. Thanks for your attention, and see you at the next lecture.